Okay, welcome to the lecture on carbon footprint. We're going to actually explore what a carbon footprint is, how it's measured, it's a way of metering our impact on the environment. We're going to look at how we compare carbon emissions per capita from a range of countries, and also talk about how sustainable development might lead to controlling greenhouse gases and allow us to achieve a sustainable lifestyle. Now, for using these notes, watch through the video, pause when you need to take notes. Take plenty of notes because this is going to help inform your knowledge of carbon footprint. And the whole point of these videos is that you can pause them as you need. I should have already sent out the lecture slides that go with this. So if you can't quite see it on the video, you can look at it in more detail. And if I go over something quickly, you can look at the detail of a graph or look at some of the examples that I may not go through fully in this lecture. Okay, so first off, the outcomes. You're going to be able to estimate your own carbon footprint. That's going to happen during the lesson. Compare emissions per capita from a range of countries. That happens early on. And look at how we can control sustainable development. Skills outcomes. We want to just develop your skills in comparing total and per values. I'm going to discuss that in a minute. When it comes to after the lecture, you're going to look at your own carbon footprint during the workshop. You're going to look at some different countries during the workshop as well, and perhaps in your own time. And we've also got a practice exam question coming up again during the workshop. So definition time, get this written down into your notes. A carbon footprint broadly is the amount of carbon dioxide or related greenhouse gases, we'll come to that in a moment, is released into the atmosphere as a result of activities of a particular individual, organisation or community. So you can have your carbon footprint, the school, Ferndown Upper, can have their carbon footprint, and the Ferndown area as a town can have its carbon footprint. Or even an item, the manufacture of a particular good, has a carbon footprint. So let's look at this map of the world. What we've got here is the size of the countries adjusted for the amount of carbon or CO2 related gases, greenhouse gases, that they emit. And as we can see, there are actually a handful of countries that really emit the majority of what's going out. Take a second to pause this, go to your lecture notes and look at this map in a little bit more detail. But what we can see, the T there, I believe, stands for, I think, teragrams, although that might need to be looked into. But what we've got here is a range, particularly the sort of Western countries, the northern countries, sort of the UK. We've got China over there, America, that are emitting way more CO2, CO2-related gases, per person, per area, than other countries might be emitting, both in total amount, but also, as we'll see in a minute, per person. A lot of the information from this is based on a book by Mike Berners-Lee, which is well worth looking at, well worth reading, and is looking at this How Bad Are Bananas? So it's really looking at the impact of things we see every day and the impact on carbon footprint of items that you perhaps consider to be quite not problematic when it comes to the environment. So when it comes to carbon footprint, it's our best estimate of the full impact of climate change on something. From something. So carbon, what we're actually talking about is things like carbon, methane, nitrous oxide, CFCs, gases that exacerbate the greenhouse effect. So we're often talking in terms of carbon, but the symbol that we use is CO2e. CO2e is not just carbon. As I mentioned, the E is there on purpose, it's not a typo. It means CO2 equivalent. Equivalent gases that are similar or give an equivalent effect to CO2. The footprint is that total impact. Click on. So what we've got here, pause this. I really recommend pausing the video here and having a good look at this chart. Oh, just a minute. This chart tells you some of the sources where some of our CO2 or CO2 equivalent gases come from. So we've got things like transportation, electricity and heat. We've got other fuels when it comes to combustion, land use, industrial processes, agriculture. It's a wide range. Oh dear. It's a wide range of sources that it's going to come from. It also tells you which types of gases are released by each source. So it's worth having a look at what's really releasing the bulk of carbon dioxide, what's releasing CFCs, where are the nitrous oxides coming from. A question could be in an exam, name as a man-made source of nitrous oxide, similar to your last exam. That could come up. Okay. So moving on. there is a concept of direct and indirect emissions. A direct emission might be a manufacturing process, or it might be you driving your car and releasing gas into the atmosphere. It might be farming, where directly the production of that cow is releasing methane and, to a degree, carbon dioxide. Indirect emissions, everything else, and these are categorized in two ways. So to give you an example, an office that uses paper clips made of steel, the steel had to be mined and will have their own carbon footprint, as well as the transport of those paper clips to the office. When you're looking at direct and indirect, and I recommend taking some notes of these three categories, there are three kind of scopes for gauging CO2 emissions. Scope 1 is direct. Have I used petrol to get somewhere? Have I used fuel, like a gas fuel, to heat my home? My parents have a multi-fuel burner. Burning wood on that fuel, on that multi-fuel burner, releases direct CO2. That's contributing to their emissions. Thing number two, sort of scope 2, is indirect, an awful lot of indirect. So things like mainly purchasing electricity, steam, heating, cooling for own use. So the electricity through my pipe has come directly from an electricity plant that probably has generated CO2 in the process. So that's scope 2. Scope 3, kind of everything else that's indirect. Factories, transportation, investments, leased assets, use of sold products. So we're going to look at the end of this lecture. China is quite a large producer of goods that impact on scope 3, all the manufacturing that China does. They're not necessarily the people who use those goods. So we're talking about a lot of these numbers. Let's give you a bit of context. 1 gram of CO2e, CO2 equivalent gases, would be produced if you burned a pea-sized blob of gasoline. So think about that. Tiny bit of gasoline or petrol produces 1 gram. 1 kilogram, about 2 pounds, would be produced for 2 cups of petrol being burnt. And 1 ton would be produced if you burned 60 gallons of petrol, like a fish tank's full. So when we're talking about tons of CO2, that's like just getting a fish tank of petrol and burning it. Now think about that. Think about the cost in your car. So you might think that driving around, and it does, contributes towards your CO2 emissions, but there are other things you can do, as we're going to see, that are just as harmful as driving around, getting a bus, that kind of thing. So the book looked at America, so it's the example that we're going to use. But the average American has a carbon footprint of 28 tons of CO2 per year. 28 fish tanks full of petrol every year of CO2 equivalent gases being released just because of their life, their daily activities. The world greenhouse gas emissions are 32 gigatons per year. Now, if you're not sure what gigaton is, pause this video, look it up, put it in your notes, and during the lesson, I'll check up and see if you've got an explanation for how big a gigaton is. It'll be one with a number of zeros. It's related to a gigabyte, if that's at all helpful for you. The global average carbon footprint is 6 tons of CO2 equivalent gases per year per person. So that's quite interesting when comparing the average American, and to be honest, in the UK, we're not that far off the average American in our consumption. We're quite a high consuming country. The average American is, almost 5 times the amount of CO2 produced or consumed from what they consume compared to the average human. So there are some countries using way less. There are some countries using way more. America, the UK, a lot of the West are definitely on the higher end of that and using more than perhaps their fair share. It's worth considering. So let's look at some examples. Now I want you to be getting notes of these because again in exam you might find it useful to be able to recall some examples in your questions. Remember we talked the other day about give an example, give an explanation. Give an explanation, give an example. That's getting your 2 points for a 2-marker question. And bear in mind we've got a 10-marker we're going to do in the lesson. So we look at sort of pints of beers, cycling, having a child, forest fires, a whole range of examples. We're going to try and explore them. Which type of beer would have the highest carbon footprint per pint? So have a little think, have a consider. Pause this and see if you can work out which it is before I give you the answer. So locally brewed at the bar, store-bought, but locally bottled, store-bought, bottled elsewhere, imported long distance. Okay. Not surprisingly, if it's store-bought, bought elsewhere, imported long distance, it's kind of, hopefully obvious, that it's going to have the higher carbon footprint because it's been transported, it's been manufactured elsewhere. That transport cost is a big chunk of their carbon footprint. And we'll talk about water in a minute. It's not so much about the manufacture in that case. Not always possible, and there's some economies of scale, but this is not ideal. A pint of beer. So if it's locally brewed, 300 or 0.3 kilograms of CO2 equivalent gases. Probably a CO2 with this one. A bit of NO2 as well. Store-bought, locally bottled, 500 grams. Store-bought, bottled elsewhere, imported long distance, 900 grams. So nearly 600 grams of CO2, extra CO2 is released because it's bottled elsewhere and then transported. It's relevant. Which food would produce the highest carbon footprint for cycling a mile? So imagine you're fueling yourself with food. Which would be the best food if you're being carbon conscious to fuel your cycling? Air freighted asparagus, bacon, and bananas. Have a think, see if you can put some approximate figures to that based on what we knew about beer. Pause it, take a guess, and play again. I'm hoping you don't find that surprising. And bear in mind, things like bacon have a quite high CO2 impact because it's meat, and we'll talk about that. But to send it that many miles takes nearly 2,800 grams, 2.8 kilograms of CO2 equivalent gases produced just to grow and transport the asparagus. Now, things like bananas are great. Bananas are fantastic. We'll talk about them in detail later, but they've got their own skin. You have to package them. They grow fairly easily. You can transport them by freight, by sea, because they don't perish as easily. Pretty good. Cheeseburgers, you've got to grow some meat, and we're going to talk in a minute. Meat is terrible for the environment, for releasing CO2. And air freighted asparagus is just that you've got to put it in a plane. It's quite perishable. It's not really good for the environment. Worse than driving a mile in a Humvee. So you'd be better off driving a Humvee than powering yourself cycling with asparagus. That's not quite realistic, but it's a good comparison. The carbon footprint of manufacturing a new car is something also worth considering. It's not just about what comes out the tailpipe of the car. It's about the cost of carbon to manufacture it, or carbon equivalent gases, CO2e. So what do you think? Do you think the footprint is very small, roughly equivalent, or very large compared to the lifetime carbon release of a car? It's about the same. So if you're driving a car for, I don't know, quite a number of years, across the lifetime of the car, it will probably produce a similar amount of CO2 than when it was made. So if you're someone who was to buy, or later in life, who was to buy a new car every 3 years, which is way less than the lifetime of a car, you're actually generating more carbon than if you just buy a car and drive it well. Even if the engine's more efficient, to manufacture that takes a lot of carbon. You've got to drive it for a long time before you see some benefit to an energy efficient car. It doesn't mean we shouldn't produce energy efficient cars, but we must be mindful that producing the act of manufacturing that has an impact. Which is why when it comes to reduce, reuse, recycle, the reduce is so important. Don't manufacture things we don't need or produce CO2. Web search. I'll come through these quite quickly, but I'd like you to look at them in more detail on the slides. But even web searching releases a little bit of CO2 for the energy, the data centers. It's not free to search. Someone's putting energy into that. Desktop computers, much more power hungry than laptops, releasing more CO2 just from the electricity use, but also the carbon released in the manufacture of them. One thing we're not necessarily including that is the cost of wearing clothes, keeping warm, burning calories. There's a few other things we can consider, but particularly if you're sort of living in a building that needs maintenance. The mere act of walking through a door, say in a hospital that's automatic, it costs CO2. So we're looking at about, I don't know if it's cold outside, you've got to heat the room up a little bit more, the temperature keep popping down a bit, and the power from the electric motor, so that's costing electricity. And we're back to bananas. Bananas are actually surprisingly good. They have quite a low carbon footprint if you have to transport something. They're grown in natural sunlight, not heated in greenhouses. So our tomatoes in the UK, heated in greenhouses. They don't spoil quickly, so we can send them by sea, which is about 1% of the carbon footprint of flying. It's worth considering. And there's no packaging. So on the whole, about 80 grams if shipped from across the world. So still not ideal getting things from far away, but not bad. Even spending money. So in our current energy system, it's very difficult to spend money without adding to a carbon footprint. But the exception of that, things that you can spend money on, is if you're doing things that reduce net emissions. So if you're looking at rainforest preservation projects, and you're putting in money so people can grow trees to capture the carbon into the tree, okay, fair enough. Maybe that's not going to add to the environmental problems. And to a degree, sort of -2 kilograms if you're producing solar panels. Now, they do have to function for a period of time. They do have a carbon cost to them when they're manufactured, but over their life, they will reduce what we would have spent on energy. So it could be argued that they are a net detractor from your carbon footprint, which is good. In the middle would be spending on groceries, because it really depends on what you spend on. So 620 grams equivalent of CO2 equivalent gases, roughly per pound or dollar. Spending on flights, clearly the worst thing you can do for carbon emissions. Flying is not efficient yet. When we invent electric planes, it'll be fantastic, but we're not there yet. It might be good if we could generate jet fuel from carbon neutral sources. So if we can carbon capture to produce jet fuel, that won't be so bad, but we're not there yet. So it will contribute 10 kilograms of CO2 per pound spent on flying. It's a lot. An £800 flight, a lot of CO2. Going on a road trip. So what's the most effective way to go on a road trip? Maybe you should cycle on a road trip, but actually when you look at it, you're probably better to get some kind of mass transit like bus, potentially, banana powered cycling compared to a bus. It's not far off. A small efficient car, not a chance. Plane, SUVs, not ideal. But maybe a bus isn't so bad. Just throwing stuff away, not even buying stuff, will cause problems. So the average US citizen in America sends 1,250 pounds of garbage to landfill. That's a lot. Average citizen recycles maybe 640 pounds of that. So not much, like 40-50%. No, a bit less than that. Landfill emissions are produced just by the decomposition. Methane is produced by decomposition of garbage. So the more stuff we can take out that won't decompose to methane is the better. But a lot of methane is produced, and that's really bad greenhouse gas. Sending metals, glass, plastics to landfills rather than recycle also means we have to make new products. And as we've discussed, the manufacture of a product can be an issue. And finally, leaving the lights on continuously, like for a year. Just leaving your lights on contributes to carbon because we're using electricity. Again, go back over some of these examples if you want to look at them in more detail. So we're coming to two of the bigger impacts you can have on your life. One you've got a chance that you might do. One hopefully is unlikely. The first is having a child. Just having a child is the single biggest decision or impact you can make on the environment, because a child over its life is going to use maybe 2,000 tons for a high impact child in America or the UK, and maybe 150 tons of CO2 released across its life for carbon conscious child or a country that uses less carbon. Still not great. That's kind of assuming reductions we're expecting as well. The only thing you can do that's worse than a child for the environment, there's also benefits to children, of course, but for the environment, is a forest fire. If you start a forest fire, you're going to release probably 1,000 times more carbon in that act than in your whole lifetime. In California, in 2008, forest fires were responsible for 231 million tons of CO2 equivalent gases being released. It's actually quite a major portion of the CO2 released globally. So if we could control forest fires, that would actually be a pretty good thing. Bottles of water. The weird trend that everyone's now drinking plastic bottles of water. When I grew up, it wasn't a thing. Started to get more common. Now people are starting to be more conscious of it. But 80 grams of CO2 emissions just from the plastic, not even the transport. Locally sourced, 110 grams. Traveling 600 miles by road, 215 grams. It's one of the more ridiculous ones, given that most of the world has access to a tap, particularly in the UK. We all have access to taps. This is completely unnecessary for most people in most countries. Not all, but in most countries. Bottled water is 1,000 times more carbon intensive than tap water. Our tap water still has to be cleaned, but it is locally sourced, and there's an infrastructure to reduce that impact. The world consumes 53 billion gallons of bottled water a year, which accounts for 1/6 of the total world greenhouse gas emissions. Let that settle in for a minute. We didn't used to do this 20, 30, 40 years ago. But now, 1/6 of a percent of total world greenhouse gas emissions, and we'll correct that, 1/6 of a percent, is just from bottled water. We could get rid of that and release a lot less CO2. I will double check, but 1/6 of a percent. It's massive from like an act that we just don't need. 2.5 acres deforestation. So deforestation, the tree growth is one of the ways of capturing carbon. So if we deforest trees, burn them, use them for something else, most activities will release the carbon from those trees, unless we're making like paper or something that will eventually decompose. So 32 million acres cleared per year. 32 million acres. 17% of all human emissions come from these trees being cleared. But also we're removing vegetation that was capturing the carbon from the atmosphere. A good forest will capture a ton of carbon as it grows and spreads. If we're cutting it down and then doing agriculture that's not good for the environment, that's a problem. Here's our percentages. Have a little look. Make sure you're taking notes as you go as well. Have a little look at these notes, okay? Take some notes down, because these are key examples that you might use in a test. This is basically what 2.5 acres looks like. This is what 1 hectare actually represents, or actually looks like. It's basically a squared off football field. Okay. 500 tons of CO2 in a hectare. Driving a car 28 times around the world. And this brings us to burgers, agriculture. So a lot of this has been cut down because of agriculture, because of food production. And a burger, to produce the meat, is the least efficient way of getting calories into us. I personally do eat meat, so I'm not saying this from sort of a judging perspective, but it really isn't efficient. So the energy that you use to live and move around comes from the sun. Yeah, some plants have fixed it, and then either an animal's eaten it or you've eaten a plant. Which is the most efficient way to transfer energy from the sun to you? Do you think they're equal? Do you think they're different? Which is the most efficient way? I'm hoping that doesn't come as a surprise. Because bear in mind, right, if you eat a plant, 100% of that plant's goodness has gone in you and your body's absorbed what it can. If an animal eats a plant, and then you eat its meat, the animal also needs energy to respire, to live, to survive, to grow, to reproduce, whatever the animal's going to do in its life. So a small fraction of that, about a fifth, I think, is going to go into you, going to go into the muscles that you're going to eat and convert. So it's just a very inefficient way of, a huge amount of the grain that the animal eats or the grass is just going to be wasted. And those animals are producing methane if they're larger sort of ruminants like cows and things. So animal products tend to be more carbon intensive than vegetables because the animals consume a lot of energy just to keep themselves warm and move around. Converting animal feed into meat and milk is inherently inefficient. Can't be argued with. In addition to being inefficient, cows and sheep are ruminants, and they belch methane and sort of fire methane as well. And beef and lamb has double the carbon footprint because of this per kilogram than, say, like pork and chicken. So one change you can make if you want to impact your carbon footprint without giving up meat is to just eat chicken and pork more often. Maybe eat a little bit less meat as well, but chicken and pork a bit more often. And this demand has caused deforestation, which is further exacerbating things. And you can see how these things affect each other. I've got some figures here. I'd like to come back and have a look at these or pause it. I'm not going to dwell on them. Using a cell phone, just using a mobile phone. I'm going to whiz through this because I think you can come back and have a little pause and a look. But using a phone, just a minute's worth of call is the equivalent of carbon that's in an apple. It's kind of interesting. In 2009, think about how long you spend on your phone, either on the internet or phoning someone. Cell phones account for about 125 million tons of carbon emissions. Now, they weren't here 30 or 40 years ago. Although, texting is a bit of a lower carbon option, using less battery. It's worth bearing in mind, these weren't here sort of in the 90s really in any big way. And it does take a lot of energy to power these masts that are sending things to phones. We're not using the landlines anymore. This potentially is a higher energy way of providing that. So typical usage of just under 2 minutes per day. Years usage of about an hour a day. So you can compare, I'm not a particularly big caller, so probably about 47 kilograms in a year. If you're actually quite a big caller, call your friends all the time, over 1,000 kilograms of carbon dioxide equivalent gases produced per year just from your phone. Computers we've discussed, but the footprint can be quite big, not just from the electricity and the servers and the networks that you use online, but also from the manufacturing of the machine, and particularly really with computers. It's the microprocessors, and it's the graphics cards if you play games on computers or do sort of cryptocurrency mining. That's where the electricity is really used up, and the manufacturing processes they're complicated. Electricity emissions typically equal the footprint of manufacture after 15,000 hours. That'd be 9 hours a day for 5 years. Now, I'm not going to hit that with my computer. So it's the mere manufacturing of my computer that's used up most of its energy. That's interesting. An international flight. So we've got some comparisons of flights. I think you can look at this when you've got your own time, but it's worth looking at how different flights cause different amounts of CO2. The reason first class is more is because you're not fitting as many people in. It's not as efficient. Comfortable, expensive, inefficient. So in an international flight, when a 747 takes off, about a third of its weight is fuel. So it has to spend fuel to carry the fuel that it needs to fly. As it burns, it creates 3 times its own weight in CO2. So we've got a ranking here. This is back to the figure, the numbers, the list that we had before, and we've got a ranking of all the different rough amounts that we've gone through. I wouldn't write down every one, but get a few good examples. Maybe learn 7 or 8 of them. Just learn those examples and approximate, in hundreds of CO2. A road trip can be about 500 CO2. A computer, a beef burger or beef and cheeseburger, about 2.5 kilograms. So just learn a handful across the spectrum of what's there. Learn that forest fires, hundreds of millions of tons. Having a child, somewhere between 150 and 2,000 tons, depending on how energy conscious they are during their life. And then we come to scope 3. I mentioned there are 3 scopes: what we use directly, what's used in the manufacture of our energy and electricity that we use, and then finally scope 3 is everything else that's manufactured. And I mentioned China produces more toys and more CO2 in all its manufacturing than anywhere else. So for scope 3, China is the big contributor, but bear in mind who it's being made for. China's not producing that for its own people, on the whole. It's being produced for other countries. So it's worth considering who's using them. So actually America is the major recipient of the benefit of that. So CO2 is being produced for the benefit of places like America and Europe, and to a degree Australia as well. And that's it. So what I would like you to do is review this lecture, and in our next lesson we're going to look at a model exam question. We're going to look at your own CO2 carbon footprint. We'll do that in the lesson, and then we're going to talk about some of these comparators and maybe some examples that we'll get down. So thank you for paying attention to that, and I'll see you next lesson.